Let's talk about turbine oil monitoring, especially on-site analysis for power generation turbines. So why should we worry about turbine oil monitoring? Well, turbines are capital-intensive critical machinery. They're usually the largest piece of equipment on a power plant. They're producing power. It's important to keep an eye on them because 20% of potential outages, force outages, can be traced back to lube oil systems or something related to lube oil failures. Lube oil systems lubricate, they cool, they provide for power transmission in the systems. They are taking care of the bearings, lubricating and cooling bearings, as well as turning gear in some designs. Also, we have electro-hydraulic control systems for the valve control. We're talking about both steam turbine and gas turbine systems that are used in power generation systems. The need and the specifications for condition monitoring of these types of turbines has been already well established in many different needs and standards. This is not an exhaustive list, but ASTM standards, GEK specs from GE, Siemens, Mitsubishi, Pratt, Whitney, Westinghouse, Toshiba, all of the majors have some sort of well-defined specification for in-service monitoring of their turbine oils. Why is that important? Well, if we look at a loop system here for a generic steam turbine system, what we have here essentially are a whole series of bearings, both on the shaft and on the generator side, as well as maybe on the turning gear. And what we have is some sort of centralized lubrication system where we're pumping fresh, clean oil up into the system and then gravity fed or pressure fed at a low rate through the bearings, and then all comes back, gets filtered back into a large reservoir. These reservoirs are quite large. They can be anywhere from, on steam turbine systems, from 2,500 to maybe 8,000 gallons of oil. That's up to 14,000 liters. And it's designed for long life. So these oils are designed to be in the system for up to 10 to 20 years, provided everything is working well. So it's a significant investment and you want to maintain it. Separately, you can have an EHC or electro-hydraulic control system. Traditionally on older steam turbines, these were a separate system that were designed to control the valve positioning for the steam. Generally consists of a fluid that was able to withstand the high temperatures that are encountered during the steam. So you'd often have a phosphate ester or Farquhar style system on the older systems. You'll still see this on a lot of power plants today. Newer gas turbine designs, they'll take the lube oil from the same reservoir. So the oil that's used, which is like an API Group 2 or Group 2 Plus, is the new design nowadays. And that's what we want to be able to monitor. The turbine oils that are usually API Group 2 or Group 2 Plus are typically low viscosity. They have specialized additives, generally a low amount of additives. They're designed, as we said, for the long life, and they're very intolerant of excessive contamination, be that water or particulates. So as a result of that, why do we monitor and what do we monitor? We want to specifically monitor water content that could be indicative of possible steam leaks or cooler leaks into the system. We want to look at particulate contamination because that could be evidence of filter bypass or seal issues. We want to always monitor acidity and oxidation because it can indicate excessive heat or oil degradation. And also we want to look for varnish byproducts on the certain designs which are susceptible to that, because that can lead to servo valve jamming or last chance filter plugging, particularly in the hydraulic control systems. So as a result of that, what are the key tests that we want to monitor? Well, for the most part, steam and gas are pretty much the same, but let's really go over the key areas. We want to look at viscosity. Why? Because viscosity is the most important physical property and it's indicative of lubricant film strength to maintain that hydrodynamic pressure on the bearings. We want to look at total acid number. It's indicative of the overall oxidation levels. We want to look at water content, usually low amounts of water. For steam turbines, it's 100 ppm is the maximum limit. We want to look at oxidation. That's indicative of lubricant byproducts. Also, for those cases where we're looking for varnish, we want to look at linear sweep voltammetry because it's looking at the additive package that's present. Particle count is critical, recommended for all systems. It's an indication of the level of cleanliness in the system and to indicate if there's any filter problems. Elemental is very important because what it does is it looks at trace amounts of wear debris that could be indicative of potential wear issues occurring in this system. Generally, we don't expect to see wear, but if there is wear, because you use such a large volume of oil, the dilution ratio is quite dramatic. So even small trace amounts of ppm, like 1 or 2 ppm, can indicate a wear problem. We want to look at ferrous contamination, ferrous particle count on gas turbines, particularly of turning gear systems, not so much critical on steam turbines. We want to look at the micropatch coulometry, which is the varnish tester. That's definitely recommended for gas turbine systems. It's optional for steam turbines. And of course, wear debris analysis is optional anytime you indicate a potential problem. So because of that, what we recommend is suggested packages for the power generation industry are all based on our Minilab industrial suite. So we definitely recommend at least a Minilab 53 because it's got the key tests in terms of particles and contamination. The Minilab 153 adds the elemental, and of course we do recommend that you also consider a varnish solution as well anytime you're rolling out your package for your on-site analysis.